Welcome to the Chapter 5 lecture. This lecture talks about measurement concepts, focusing mostly on reliability and validity. When measuring anything, we have to keep in mind the type of scale of measurement that we have and the benefits and limitations they have. We talked about the scales in chapters 12 and 13, but we'll review them here again quickly. Nominal scales are used for categorical variables, or variables that have to do with names. This may be categorizing people based on eye color or college major. Ordinal scales are for rank order data. So what place someone wins in a race, or how many stars a restaurant has. And as a reminder, we do not know the distance between these numbers. With interval scales, the intervals between numbers on the scale are all equal in size, so we do know the distance between them, but there is an arbitrary 0 points. Temperature is a great example of this, right? If something is 0 degrees, it doesn't mean that there is no temperature. And lastly, ratio scales have an absolute 0 point, meaning that there is an absence of the variable being measured. So this might be length, time, speed, or anything of that nature. Reliability is the consistency or stability of a measure. Reliability in research is like reliability in everyday life. If you have a friend that's reliable, you can count on them, right? It's the same thing in research where a measure will give you the same result each time you administer it. When we are looking at reliability, we want to look at the true score, which is an individual's actual score on a variable being measured, as opposed to the score the individual obtained on the measure itself. So how intelligent is someone versus the score they received on an intelligence test? A good test will have a very similar result to the true score. However, we don't usually know the true score, right? If we did, we wouldn't need this measure that we have. Because this is called measurement error, which is the degree to which a measurement deviates from the true score value. So yes, your intelligence test might be off, but how much is it off each time you administer it? An unreliable test will have variable amounts of measurement error. Sometimes it's 20 points off, but sometimes it's only 2 points off. A reliable test might be a little bit off, but it doesn't vary in the same way. Say it's only 2 points off every time you administer it. Establishing reliability depends on the measures being used. It can include training researchers on how to report behavior, phrasing questions correctly, or making sure electrodes are placed correctly each time. And reliability tends to increase as the number of items or measures increase. Reliability is assessed with statistics through correlation with other measures that should be related. If two measures should be similar, the scores on those measures should be highly correlated, and that is called the reliability coefficient. With the intelligence example, we could see if the numbers relate to, say, academic test scores and see if there's overlap there. We can also examine test-retest reliability to see how reliable a measure is. We test a group of participants, see how they score, and then test them again to see if they score in the same way. If we are testing something like intelligence, you wouldn't expect all participants to score wildly different the next time you administer the test. But we also have to worry about the measures being used. Depending on the test, people might score better the next time around because they know what questions are going to be asked. And this might mess up or bias your results. To account for this, we might use alternate forms reliability, where we administer two different forms of the same measure to the same individuals at 2 points in time. If we are looking at mathematic intelligence, maybe we give the same equations, but change the numbers being used. Or if it's a memory test, we change up the words they have to remember. Internal consistency reliability is reliability assessed with data collected at one point in time with multiple measures of a psychological construct. So instead of waiting to test a participant at a later time, we are measuring people at one time point and then examining components within that test to measure the reliability. And there's a few ways that we can do this. First is split half reliability, which is a reliability coefficient, which is determined by the correlation between scores on half of the items on a measure with scores on the other half of a measure. This could be odd questions versus even questions, or the first half of a test versus the second half of a test, depending on how the test is split up and how similar the questions are to each other. If questions 5 and 6 are very similar and 7 and 8 are very similar, then it might be good to do odds versus evens so you're comparing apples to apples and not apples to oranges here. The second is Cronbach's alpha, which is an indicator of internal consistency reliability assessed by examining the average correlation of each item, or each question in most cases, in a measure with the other questions. So this is the idea that questions of a similar nature should be highly correlated. If you're measuring happiness and joy, those should be similar. If you're measuring happiness and sadness, you might expect an inverse relationship there. Then we have item total correlation, which is the correlation between scores on individual items with the total scores on all items of a measure. So if you have a measure of happiness measured on a Likert scale and there's 5 questions, how people respond on questions 1, 2, 3, 4, and 5 should all be related because they're all measuring similar things to get to that overall happiness score. If something doesn't correlate, maybe it's just question 2 or just question 3, that question should typically be removed to increase the reliability of that measure. We also have inter-rater reliability, which is the extent to which raters agree with their observations. So 2 people measure something and then meet up afterwards to make sure they have similar results. In my undergrad, I had a really amazing opportunity to work in a lab and listen to therapy sessions with people who were heavy alcohol drinkers. And my job was to identify statements that may lead to engaging in what we call incompatible behaviors. For instance, if someone enjoyed going to the gym, they probably couldn't do that drunk, so we would try to encourage more of that behavior to reduce their drinking. So I would listen to these sessions, write these statements down, and then match up my notes with another researcher to make sure that we identified the same things. The closer we were, the greater the inter-rater reliability. But it's important to note here that while reliability tells us whether we get the same answer each time, it doesn't tell us if we are getting the right answer. That's where validity comes in. Construct validity is the extent to which an operational definition of a variable accurately reflects the underlying theoretical variable. Is the measure measuring what we want it to measure? Is a test actually measuring intelligence or emotion or whatever your construct is? And we do have some indicators of this. First is face validity, or the measure appears to accurately assess the intended variable. This is quite subjective and intuitive. It would be like saying someone scored high on an intelligence test and they also acted intelligent. What does that mean? And what it means might differ from person to person. Then there's content validity, in which the measure is compared to the universe of content that defines the construct. So if we are creating a measure of extroversion, we will want questions that tap into facets of extroversion: activity level, sociability, sensation seeking, positive emotionality. These things are aspects of extroversion, and we want to make sure we are measuring those things. We also have predictive validity, which examines the ability of the measure to predict a future behavior. Does the extroversion test predict how many parties someone attends the following month? Or maybe you see if standardized test scores predict academic achievement in college. Concurrent validity examines whether groups of people differ on the measure in expected ways. It might be that people with diagnosed depression score higher on a depression questionnaire than those without diagnosed depression. Or it might be self versus others. Does your score in a personality test relate to how your family views your personality? Convergent validity examines the extent to which scores on the measure are related to scores on other measures of the same construct or similar constructs. So if you're developing a new measure, it should be related to previously established measures. If you're creating a new intelligence test, it should be related to previously standardized intelligence tests. Discriminant validity is kind of the opposite and examines the extent to which scores on the measure are not related to scores on conceptually unrelated measures. So we wouldn't expect someone to score high on both a test of extroversion and introversion. If we think these are opposite ends of a spectrum, we would expect opposite results. But we also have to be aware of reactivity in research, which is a problem of measurement in which the measure changes the behavior being observed. Someone might just act different being in a lab. If we tell someone we want to study how clean their house is, they are likely to clean before we go over, right? It's a reaction to the study. It's just something that we need to have in the back of our minds and try to brainstorm different ways to bypass this. Maybe we need to go to the house randomly or what have you. So the activity for this chapter is pretty straightforward, not as much to write about for this discussion post. You are to state the level of reliability, so either low or high, and the level of validity, either low or high, for each of the targets. So target A, target B, target C, and target D. And please let me know if you have any questions. The hope for this is that it's pretty straightforward and pretty easy, but if you have any difficulties with this, please don't hesitate to contact me.